Recording. A person is riding on a Ferris wheel. It takes 2 minutes for the wheel to go all the way around. So that means the period is what? 2. 2 minutes. So every 2 minutes, that wheel is going to do a rotation, which means every 2 minutes, the graph will repeat. Okay? The person's vertical distance from the ground ranges between 3 and 75 feet. What did I just give you right there? Good, the min and the max. Did anybody actually draw their wheel like I told you to do on Friday? Okay, draw your wheel. If the min is 3, that means the Ferris wheel is 3 feet off the ground, right? Okay, if the max is 75, that means at the very top of the Ferris wheel, you'll be at 75 feet. What's the middle? 39. Good, between 3 and 75, the middle is 39. Good. So is everybody okay with 39 being the number that's in the middle of these two? If you're not, add 75 and 3, that's 78, and then divide it by 2. Find the middle. Okay? So we know the midline is 39, which means the end of my equation should have said what? Plus 39. Very good. Up here. All right, then what Grace said, which is the next easiest thing to see from your picture, the midline is how many away from the min and the max? 36. Good. So 36 is the amplitude, which means it goes out front. We okay with that? Okay. So we need to talk about, for the rest of it, what the distance from the ground of a Ferris wheel would look like if we graph it. Okay, so I am going to get my graph really quick just so we can discuss this, because we need to figure out if it's a sine or cosine function. Okay, so when she gets on the Ferris wheel, it said nothing about her getting on, or the person getting on at a certain foot or a certain time, right? So there's no phase shift. We're just starting at 0. So if the person gets on the Ferris wheel at the bottom, and it starts here, what happens to their distance from the ground as they ride the Ferris wheel? So they start at the bottom. So first it's going to go up. So I need to draw this wave going up. Good. And then it circles back around and it'll go down, right? It's cosine because both ends end the same way, meaning it is even. That's what you should think about. Now I know exactly why you said sine. Anybody else? Good. What's the cosine graph supposed to look like? I missed y'all. The cosine function is supposed to open up like this. So it's still even, it's just opening down now. So that means what's out front? A negative. That's it. So it is a cosine function. It's even because when you ride that Ferris wheel, it goes up and then it comes right back down. They both open the same way. Is everybody okay with how we figured out it's a negative out front and a cosine function?
Okay, so it opens up the same way.
Right.
That negative.
It's negative because your cosine wave is supposed to start at 1 and end at 1. And your cosine wave goes down. It's okay. I'm going to go graph it for you because some of y'all just need to see.
Yeah.
Which is why I told you to use Desmos on your quiz, but I could tell that a lot of you did not.
Why did it? I don't think I put it right.
And I'm zoomed out, so let me zoom in for y'all. All right, the cosine wave starts at 0, right here, and it goes down first. Our Ferris wheel needs to go up first. Does that make sense? Okay, are we sure? Ask a question if you're not. So we're going to take this same function. We're just going to reflect it because we need it to go up and then down. But it is even. We want this one part of the way, so it does need to be a cosine function. Everybody's okay? Okay. So I'm going to go back to my paper. People at home, y'all got to ask me questions on your virtual week if you have them.
There's no value, but negative, you have to put -1 or
You can just put negative. Yep. All right, so what's the only other thing we're missing? The period. There is no phase shift. I did not say the person gets on at 5 feet or the person gets on at 10 feet. There's no shift. They're getting on right there at the bottom of 0. Are we okay with that, my boys? Y'all are quiet. All right. So the period, what did I tell you the period was? How long does it take for the wheel to repeat? 2 minutes. What is the period of cosine supposed to be? 2 pi. What do I multiply 2 pi by to make it equal 2 minutes? Is it 1 over pi? Good. Y'all had me guessing for a second. Very good, because I heard different things. Yeah. So whenever you're trying to make the period equal what they gave you, you start with 2 pi and you figure out what did I multiply by to get what they said it was. So what do you multiply 2 pi by to get 2? You need the pi's to cancel. So there should be a pi in the denominator here. Are y'all okay with that? So if we want to multiply by 1 over pi, what should my equation say? Pi. Just pi over 1 or pi. And then you need your x. Some of you got points off on your quiz because it said write a function or write an equation, and y'all didn't put y equals. In math 1, you learned an equation has to have an equal sign. Could have counted it more than just a point or 2 wrong. That was nice. Make sure on your test you put y equals, or some of you put f of x equals, which is fine too. Y'all know they mean the same thing. Y'all okay with setting up this equation? I would make sure you can do this for your test Friday. There's literally one just like this. You don't know how to do it? Come to office hours. I'll give you a couple of extra practice ones, okay? We'll also do another one of these in the warm-up tomorrow. Y'all are good with writing the equation, though. That's the hard part. If you can get the equation, where can you go put the equation for the second question? In Desmos. People at home, are we okay with this equation?
Yeah, I have a question.
Okay.
So we can, like, even if it doesn't come from the unit circle for the period, we can still use 2 pi.
Yeah, so anytime you're writing a sine or cosine function, it automatically does come from the unit circle.
Okay.
Functions come from the unit circle. So sine and cosine start repeating after 1 trip around, so after 2 pi.
Okay.
Yep, so that will always be the period of those. Good question. Anybody else before I switch to Desmos? You can still ask if your internet's lagging or something and you need to ask. All right, y equals -36 cosine of pi x plus 39. All right, so I'm going to zoom out. Try to find our Ferris wheel. It is, so it goes up to 75 feet. So I do want to show y'all this also because a lot of you talk about, I don't know why this is. No, so the zoom fit button is only there when you type in a table. So let me show y'all this real quick. The settings button. We know that our Ferris wheel goes from 3 feet to how many feet? 75. So I'm going to make it go up to like 80 so I can see the top, okay? You can change what your graph ranges from. My x-axis, I highly doubt anybody would ride the Ferris wheel for 20 minutes. So I'm going to put like 10. And then get out. And doesn't that look a lot nicer? Okay, let me move my people. And let me make my, yeah, it's cut off down here. I don't know why. But can you see it down here? Okay. People at home, y'all can see our Ferris wheel ride, right?
Yes.
Okay. So the question for part B says if the person rides the Ferris wheel for 6 minutes, so we're going to stop right here at 6. I'm going to cut it off right here. Everybody's okay with that, right? Okay. When are they above 60 feet? So what you can do is go to a new box, type in y equals 60, and then it'll give you the points where it is intersecting 60, and you're going to look above that. Does that make sense? All right, so in the first trip around, when is he going to be above, or her going to be above 60? Okay, good. 0.7. You could also put 0.698. It'll tell you how to round. Okay. 0.7 to when? 1.3. Very good. All right, that's only the first trip around. We're going for 6 minutes, right? So let's check the second one. They are also above 60 at 2.7 and 3.3, right? So how do I write another interval? What do I put in between them? Good. This is why I told you this unit combines the unit circle with functions. So 2.7 to 3.3. Union, the last one until 6 minutes, because 6 minutes is right here. See where my mouse is over here, Chris? So I only care about these last two. 4.7 to 5.3. It's the same 302. It should repeat because it cycles. Did everybody just hear what he asked and how I answered him? Okay, do y'all see how, that's okay, I'll explain it to you. Y'all see how all these decimals are the same? The 0.302, 0.302, 0.302, 0.698, 0.698, 0.698. It's a sine or cosine function. It should repeat. So do you guys notice that each of these x's, or each of these first ones, I shouldn't say x's because this is an interval, are 2 minutes away from each other? From 0.7 to 2.7 to 4.7? Why do you think they're 2 minutes away? Yeah, that's the period. That's how long it takes for the Ferris wheel to end up where it started. And then look at these. Are those 2 minutes away? Then you know you did it right. If they don't match your period, you did something wrong in your equation. You need to go back and look at your equation, okay? There are many ways to check yourself on this stuff. Any questions about the warm-up? Anybody?
I have a question about the first part. You said we could do we could do a negative cos, right? A negative cosine.
It should be negative. Yep.
Okay.
Right here.
Or then we could do like a regular sine though, like a 36 sine. Or
So if you do a regular sine, this is actually a great question, KJ. Extra credit. I want everybody to look at this graph. If you do a regular sine function, the midline would start at 0. So remember what the sine function looks like. I'm going to do it in green, and I'm going to make it big. If it was a sine function, it would be here, and it would make an S. So I would not do a sine function for this one. Could anybody tell me why? So Kevin, what'd you say? You and Grace both said it. Yes, if you did a sine function for this one, KJ, that would be this piece right here. It's not on 0, which means there would be a phase shift. And the problem didn't give me a phase shift. All right, parametric equations. I think I'm going to start this a little differently. Does anybody know what parametric means? No one. I usually have someone at least try to guess. That was actually very good. I think you just guessed too. So what'd you say? 2 measurements. Parametric means 2 measurements. Okay. Write that down. Good job, Taryn. 2 measurements. Kendall, I think that's what you were saying too. I just couldn't hear you. You're so far away. Yeah. 2 measurements. So A parameter is a measurement or factor that two systems have in common. So one more time, a parameter is a measurement or factor that two systems have in common. Yeah. You can move them behind you if you want. You're not Jeremy, so if they're not in your way, I'm fine with them just sitting there. It's up to you though. You can move them if they're in your way. All right, real world example, because a lot of you are athletes. Daniel's distance he runs over time and the temperature outside over time. Does everybody agree those are two different scenarios?
Yes.
The distance he runs over time and the temperature it is outside over time. Do they have a measurement or factor in common? Good. Time, right? Almost anything in the real world will have time in common with each other because time usually, what do I want to say, affects whatever we're doing. Okay? Is the temperature related to his distance that he runs? It can be. I like that answer. It probably is. If it's very cold outside, especially when you get my age, really hard to run. Is Brody up here today? Because he would appreciate this. I'm sad he's not. Natalie, you'll have to tell him I did a running example. Okay? When it's cold outside and you try to go run, your throat like burns, yes, from breathing, and your knees ache. Maybe that's just me because I'm old, but they hurt worse when it's cold. Okay? If it's warmer outside, a little bit easier to run until it hits like what? Like 100. It gets 80 degrees and I'm like, whew, this is too much. Okay? So even though we're talking about Daniel running over time, the distance he goes over time, and the temperature over time, they're probably related and they have time in common. Does everybody understand that? Yes? Okay. I'm not going to write that down exactly, but we're going to do Daniel's distance over time. And I'm just making up numbers so no one make fun of Daniel and say he's slow or something because I have no idea how this is going to end out, okay? There's Daniel's distance over time. Does everybody see how time is right there? And there's his distance. Okay. And then what did I say? Temperature? I'm going to do a capital T. Again, I hope this works out, but I have no idea. Because I just made it up off the top of my head. I wanted to go a little rogue today. Y'all are like, oh God, we're scared. All right, Daniel's distance, depending on time. The temperature outside, depending on time. It's usually almost always colder in the mornings. It was very foggy this morning. I almost hit a runner in my neighborhood because I was kind of driving fast.
A car just like appeared out of nowhere.
Yeah. All right. What if I asked you to write Daniel's distance depending on the temperature? Could we do that? How? Okay.
would you need to find his distance he ran?
Okay, good. I'm hearing different things. Good. I'm not meaning to cut you off. They said something too. So if we were talking about KJ, like horizontal distance and vertical distance, and both of them were over time, then yes, you could find the distance between the two. But I'm talking about distance and temperature. So you can't find the distance. But what they were saying in class was, okay, if we can solve the temperature for T, then I can plug it into the distance for T. Does everybody understand that? That's how you do parametric equations. You literally solve one of them for time and plug it into the other one. It depends on how they ask you to set up the function. So if I say Daniel's distance depending on the temperature, the dependent one has to be solved for time and plugged in. If I say the temperature outside depending on Daniel's distance, then this would be the one that would have to plug in. Does that make sense? But if I want Daniel's distance depending on the temperature, I can solve this temperature for lowercase t and plug it into this one. Does that make sense? KJ, there is one actually on the test. You read my mind, which is creepy. There's one on the test where you can just find the distance. Yep. Are y'all okay with this though? It's low-key math one, to be honest. Like solve one, put it in the other one. Okay? How would we solve this for lowercase t? Take the square root of both sides. So square root of uppercase T equals little t, right? And so now where can I go substitute this in? Good, right here. So Daniel's distance, depending on the temperature, will be 2 times the square root of big T minus 1. That's it. Then where could you go put this equation? In Desmos, and you could answer whatever questions they asked you about it, right? So the main thing with parametric equations is being able to solve one, plug it into the other, so that you get one function for both things. Are we okay with that? Are y'all sure?
So far, I understand.
Okay, that's it. There's no so far, like that's literally what we're doing today.
Okay.
It's not bad. I will throw in an application problem, but we started off with one. So I will throw in a word problem at the end, and then there will be parts where it asks you to answer questions about the graph, so we'll go look in Desmos, okay? But that's, I mean, they're not hard if you understand what they mean. I do want to write down steps because I know some of you are steps people. All right. So steps for finding a rectangular function. Does anybody know what a rectangular function is? So a rectangular function is just a normal function. We call things rectangular because we graph them on a coordinate plane. So I'm basically saying, how can you take the two parameters and make it a function? We will learn about a different kind of graphing in Unit 8. So that's why I'm saying rectangular right now. If you see the word rectangular, I just mean make it a function. So steps for finding a rectangular function from parameters. I guess I should have put from parameters, but that's okay. Step 1, what do we do? Solve one of the equations for the okay, it was time, but time is what they had in common, which meant time was the parameter. There we go. So you're going to solve one of the equations for the parameter.
Miss Poole,
Yeah,
didn't you say you solved the equation that's the dependent one?
good. If they give you a specific one, Sydney, very good. So if they
Okay.
tell you to write the function a specific way, telling you which one's the input and which one's the output, then that's the one you'll have to solve for. The examples I'm doing today don't tell you. So that's actually what we're about to write next.
Okay.
Very good question, extra credit. If they don't tell you which one to solve for, let me just give you an example. Which one do you think we would solve for? X and plug it in because X is normally the T is the parameter. That's what they have in common. The input, good. X is normally the input, so that would be the one you would solve for T, and then go put it into the other one so that the input in Y has X's in it. Does that make sense, Sydney?
Yes, it does.
Okay, so if you have this one, we're typically gonna solve for X or solve the X equation. You need glasses. We talked about this last week. I just roasted you. I didn't mean it to sound that ugly. Typically solve the X equation because X is the input. Cody hasn't told me he can't see my green. So I think we're okay because he usually tells me.
Cody's got better eye. I don't think Cody's got 20/50 in his left eye. Oh, you got 20/50 in your left eye? I don't know.
Oh boy said 20/50. My vision is 21. I think it's 21/75 or 22/75, something real bad.
My right eye is 20/25.
All right, we're gonna solve the input equation for the parameter and then go input it into the other one, right? So step 2, substitute the solved parameter into the second equation. And what is that second equation typically going to be? The output equation, the Y equation. Good. The output equation. Substitute the solved parameter into the second equation.
Second equation.
Uh-huh.
I just bad type now. And math too, you can solve for X and Y by.
Yeah, so this is just like in Math 1 when you did systems of equations. I'm actually starting that in 2 weeks with my Math 1 babies. Pray for me. Some of them can't solve an equation. And where you substitute in and find where they cross, it's literally a Math 1 topic. We're just putting a pre-cal spin on it, okay? Can we do, my voice just cracked really bad. Can we do like one example and then you guys try one? And then I'll do a word problem and we'll be done? Fantastic. All right, example 1. Solve for the parameter to write the rectangular equation. X of t is 6. Y of t.
That's confusing.
I get to teach FOIL today in Math 1. First, outer, inner, last, box method, multiplying. Next week, I get to teach factoring. Very exciting. It's so hard to go from teaching y'all and then by third period to Math 1. Yes.
Hard stuff to easy stuff.
All right. If we want to write the rectangular equation and they give you an X function and a Y function, which one do you think is the input?
X,
The X function, so which one do we need to solve?
Y. Oh, we need to solve for X.
We need to solve the X function for the parameter, which is what if it's two T's? T. Time, sure. They didn't tell you it's time, so you don't know that, so I'm just going to say T. Okay? So we need to take our X equation and solve it for T. So what would I move first? You would subtract the 6. So this will be X minus 6 equals 2T. Good. So hang on. I want to make sure we understand X of T just means X. This is the X function that has T as the input. So you can just write X. Okay? All right, divide by 2 on both sides. So X minus 6 over 2 equals T. You will probably want to go ahead and simplify this first before you substitute in. It's not X minus 3. Good, Cody. Extra credit. 1/2 X minus 3. Remember, they are both being divided by 2. So X over 2 is 1/2. 6 over 2 is 3, and it was subtracting. No, thank you, Grace. What am I on, like 2%? Extra credit, thank you. My Zoom would have died and everything. Y'all would have been SOL. All right, what do I do now that I have it solved for T? Good, go put it into the Y equation and solve. So I'm going to take 1/2 X minus 3. I'm going to come up here. Oh my God. And put it in for T. Yes. It's kind of like composition of functions. Yep. So Y equals 2. What am I putting in for T? Good. 1/2 X minus 3. I'm squaring it and then subtracting 2. Y'all are okay? All right. You can put X over 2, but we're about to have to simplify. I want it in standard form, which means I have to do what? No, not factor. Good. Box method or FOIL, because this says 1/2 X minus 3 squared. So 2, 1/2 X minus 3. If it's squared, I write it twice, and then I'm going to have to multiply minus 2. There was a reason why I was telling y'all what I was doing in Math 1. Yeah, they're about to be doing the same thing y'all doing. Sorry, Daniel. I feel like my head's in the way. All right, listen to me very carefully because some of y'all messed this up on the first test, although I don't know how. I need to go have a discussion with your Math 1 and Math 2 teachers. You do not distribute the 2 first. You do the parentheses first. Hashtag PEMDAS. I don't know why some of y'all moving that 2 first. PEMDAS, parentheses first. 1/2 X times 1/2 X. Then we're going to do 1/2 X times -3. There's my first and my outer. Then I'm going to do -3 times 1/2 X. And then -3 times -3, right? I just want to make sure we get it right this time because a lot of y'all for real did mess up on this on the first test. So let's make sure we're foiling properly. I'm not messing with the 2 yet. What's 1/2 X times 1/2 X? Very good. 1/4 X squared. What's 1/2 X? This is going to be messy. Times -3. Good, Kevin. -3/2 X. Actually, it's not going to be bad. And then the middle is going to be -3 times 1/2, which is -3/2. You're moving ahead of me, but yes, yep. And then -3 times -3 is 9. And then the -2 is on the outside at the end. Just want to make sure we don't miss this time. Everything you learn in pre-calc cycles back. So what Kendall said was the middle terms inside the parentheses, if you have 3/2 and 3/2, That makes 6 halves, which is just 3. So this is minus 3x plus 9, and then minus 2. Probably should move this because I think the people later may not be able to see it. All right, so now what do we do? Now you can distribute. So this is gonna be 1/2, right? 2 times a fourth is a half. Okay, 1/2 x squared. What's 2 times negative 3? Negative 6x. What's 2 times 9? 18. And I'm gonna go ahead and do this in my head if it's okay with y'all. What's 18 minus 2? So this should say plus 16. That is the rectangular equation for these two parametric equations. So I solved one more time. I found the input equation, solved it for t because that's what they have in common. And then I substituted into t in the other one, and that's your rectangular equation. Y equals, and it's got x's. So we're done. Then whatever questions they ask you about it, where could you go put this equation? In Desmos. Are y'all ready to try one? Can I talk about the negative 3/2 x? So she saw, okay, this will be half of 3 and this will be half of 3. So if you put 2 halves of 3 together, it'll make a whole 3. Okay. If you put these together down here, Chris, which is what he was saying, 3 plus 3 is 6, but over 2 would be 3. She just looked at it and said, right? Is that correct? Is that what you looked at? Half of 3 and half of 3 would make a whole 3. Yes. And I don't teach it that way because I teach math 1, and they would never get it right. They would write 6 all day, and I'd be like, son of a gun. All right, I'm gonna give y'all one to try, and then if we have time, we'll do an application problem. If not, we'll save it for tomorrow because we kind of already did one. So this is y'all's to try. Same directions as before. So I want you to find the rectangular equation, but then I'm gonna give you some questions for it, okay? So x equals square root of 2t. Y equals 4t. And they're telling you t has to be greater than or equal to 0, which doesn't matter. So no one freak out about it. That just means we're only looking at the positive part of the graph, right? Okay. Every year I have somebody freak out about that. All right. A, I want the rectangular equation. B, I want you to find the x and y coordinates when t equals 8. And C, oh my God, I didn't finish writing. You can use Desmos. You got to find the equation by hand, but then you can use Desmos. Try this one. People at home, y'all try it too. So just like the last one, find the rectangular equation first, and then answer these two questions from it. Are y'all already done solving and plugging in? Smart kiddos. You want me to come check you and make sure you did it right before you start doing the Desmos part? So it would be 4x squared over 2, which would be, you're just multiplying. And then you should be able to simplify that. Two. Good. Yep. You good, Daniel? You're just thinking. People at home, unmute if you have a question. All right. Did we square both sides of the x equation? Hello? Yes? Great. So x squared equals 2t. And then what did you do? Divide by 2. So did everybody get t equals x squared over 2? Okay, that means we can go put this x squared over 2 where? Into the y function for t, because it says t equals, right? So my y equation would be y equals 4 times x squared over 2. And then this is where some of y'all messed up. So make sure you're paying attention. 4 hasn't understood what as its denominator? 1. So denominator times denominator, 1 times 2 is 2. Numerator times numerator. So you're going to get 4x squared over 2, which reduces to what? Very good. So this is your rectangular equation. Yes, ma'am. If it wants a rectangular equation, x should be the input.
No, I know, but like when you're doing
Yeah, so yep. So she asked if you could solve the y equals equation for t and then plug that into x and just solve for y. You can do that. I don't do it that way because it tends to be an extra step normally. So I usually always solve the x one, but you can do it. Just remember, if you solve the y one for t and plug it in, you have to put whatever you get in y equals. Okay? But yes, you can do that. All right, rectangular equation, we're good. I think this is where some of us were messing up. You cannot go put 8 right here. Why not? Yes, not x. It says t equals 8. So where did you guys go to find the x and the y when the time is 8? Good. Put it into the original. So everybody look at this. X will equal the square root of 2 times 8 if I put 8 in for t. What's 2 times 8? What's the square root of 16? 4 or negative 4. Which one do we keep? Good.
Positive
4
because
because it's a
negative.
4 because it's greater than 0. Did you guys go look at this graph in Desmos? It's a parabola, but we only want the positive side. Does that make sense? We want when time is going up. So we want the first quadrant. All right, so x should be 4. What did y'all get for y? Good. So y is 32. So then the ordered pair, the x and y coordinates would be 4, 32. Questions on that one? Y'all are okay? X comma y, it says coordinates. So 4, 32. I just wrote it as a coordinate. All right, what value of x gives an output? A couple of different ways you could have done this one. I saw some of you went in Desmos, graphed y equals 2x squared, and then you typed in y equals 12 and saw where they crossed, because that would be the output, right? If the y was 12. You could have also done this by hand. Take your equation. Where would I put in the 12? For the y, it says output. So you also could have just solved it by hand real quick. 12 divided by 2 is 6. So x would be the square root of 6, which if you typed this in Desmos, does anybody need to see me put this in Desmos? You get 2.45, which is what I got by hand. So it does not matter if you want to do it by hand, do it by hand. That's faster for me than pulling up Desmos and doing it in there. I'm totally fine with you using Desmos. Do we have any questions on parametric equations? I feel like it should be like a blast from the past. Should feel like you're in math one.
I have a question.
Okay.
Why can't it be negative square root of 6?
So we want where time is increasing. So I am going to go graph this in Desmos just so everybody can see it and understand. All right, everybody look at this. Y equals 2x squared. I'm going to zoom out. So I agree the parabola does have both sides, but where the time would be increasing, I don't want to pause, I want to draw. When you graph time, because I don't think you were ever shown this, if we're talking about like the time increasing, what could be a real world example of a dip like this? Taking you all the way back to math too. Dang, really? How about a submarine? An airplane swooping down and going back up. Sure, a bird swooping down to pick some dead roadkill up. Divers as well, great. That a U shape, right? As time increases, that means it's moving to the right. So where time is bigger than 0, because that would be positive or increasing, that's only going to be this side. Does that make sense, Ann?
Yes.
Okay, perfect. All right, listen to me about your homework. It says graph by hand. Do you think I want you to graph by hand? No, I just forgot to white out it out, and there's 15 worksheets, and I didn't feel like doing that by hand on every single one. Don't graph it by hand. Listen before you do something wrong. All I want you to do is find the rectangular equation like we did in class, and then check that equation in Desmos and make sure it's a function.